Good morning to all. This is Divya, working as Assistant Professor in the Department of ECE, R.M.K College of Engineering and Technology, Chennai. In this video, we are going to see the subject signals and systems, on which the topic is periodic and aperiodic signals. Let's get into the topic now. First, let us see the difference between the terms periodic and aperiodic signals. A signal that repeats itself after some amount of time or after a time period can be called as a periodic signal, which means it has a regular pattern that will be repeated in some amount of time. So, when you are able to say that signal is repeating itself, we will be able to describe it with the help of some equation, some mathematical equation. So, the periodic signals will be having some mathematical equation to describe them. And the repetition time is called as fundamental period. This can be found for a periodic signal. Since we are able to determine the value of a signal after some amount of time, these signals are called as deterministic signals, and they are also called as power signals. Example for that is pendulum activity, because pendulum will be repeating its pattern, and this can be graphically represented by waveform like this. For aperiodic signals, they don't have a pattern to repeat after some amount of time. Since they don't have a pattern, we don't have an equation to represent them. Since we don't have an equation or pattern, we don't have a fundamental period that can be found. Since we are not able to predict any value of a signal after some amount of time, these signals are called as random signals. They are also energy signals. Some example, chaotic signal is an example for this. And the waveform is the time delayed unit step signal is an example for aperiodic signal. Why? Because we can have a value of unity for t greater than or equal to 1. For t less than 1, the value is 0, which means signal is not having a repetition. It has only constant value. Now, we have some conditions for periodicity. Let us see it in continuous domain as well as discrete domain also. In continuous domain, a signal is said to be periodic if it satisfies a condition x of t is equal to x of t plus t, where t is the fundamental time period, which means after the amount of time t, signal repeat itself. This fundamental time period t is equal to 2 pi by omega, where omega is the fundamental angular frequency represented in radians per second. In discrete domain, next signal is said to be periodic if it satisfies a condition x of n is equal to x of n plus n, where n is the fundamental period. And this fundamental time period n is equal to 2 pi m by omega, where m is the fundamental angular frequency in radians per second, and m is the smallest positive integer that makes n as a positive integer. So now here we have to remember two formulas. One is x of t is equal to t plus t in continuous domain, x of n equal to x of n plus capital N in discrete domain, and fundamental time period t is equal to 2 pi by omega. This is for continuous domain. For discrete domain, n is equal to 2 pi m by omega. Now let's see how to find the periodic nature. These are the steps to find the fundamental period. If our signal is CT signal, we will be having omega, angular frequency. From omega, we can be able to find the value of f. Omega equals 2 pi f, so we will be able to find the value of f. After finding the value of f, we will be able to find the value called t, because f is equal to 1 by t. We will be able to find this. If our signal is dt signal, then also we will be having a value called omega. From omega, we will be able to find the value called f, because omega equals 2 pi f. And for f, we will be finding a value called n, where f is equal to m by n. With this, we will be able to find the value for fundamental period both in CT domain as well as DT domain. So remember, the condition for periodicity is x of t is equal to x of t plus t. DT domain, x of n is equal to x of n plus n. So if after finding the value of t and n, how can we find the signal is periodic or not? Means if n is rational, then the signal is periodic. If n is irrational, the signal is aperiodic. Rational means if n can be represented by a ratio of two integers, then we call it as a rational number, then the signal is periodic. Similarly, for CT signal is said to be periodic if the value t is rational. It is said to be aperiodic if the value of t is irrational. So rational means signal is periodic. The fundamental time period is irrational means the signal is aperiodic. This is common for both CT as well as DT signal. So we can also find T is equal to 2 pi by omega directly. We have some special cases over here where our signal is a combination of 2 or more signals. For example, let me take x of t is equal to x1 of t plus x2 of t plus x3 of t. We have 3 signals over here. x1 of t will be having some fundamental time period called t1, x2 will be having its own fundamental time period called t2, x3 will be having a fundamental time period called t3. So, what is the fundamental time period of the combined signal x of t? Means it is the LCM of all the t1, t2 and t3. We have to take the LCM of all the time periods, then that t is the fundamental time period of the signal x of t. In discrete domain, if x of n is equal to x1 of n plus x2 of n, here we will be having fundamental time periods n1 and n2 for x1 of n and x2 of n. Then n is equal to LCM of n1 comma n2. So these are special cases where we have to consider more than one signal means. Let us see some examples over here. Taken 6 examples. We have to check whether the signals are periodic or not. Let us take the first signal, x of t is equal to sine 5t. So what is the first step for us? We have to find the omega value. Omega value is equal to 2 pi f. So for this question, omega is equal to 5. So I have written 5 is equal to 2 pi f. From which we have to find the value of f. F is equal to 5 by 2 pi. T is equal to 1 by f, we know about this. So t is equal to 2 pi by 5. I got the time period of fundamental time period of the signal. X of t is equal to 5 pi t. Here t is not a ratio of two integers. We have a term called pi. So t is irrational. So the signal is aperiodic. Next we go for the second question. X of t is equal to sine 12 pi t. So formula omega equal to 2 pi f. In this question omega is equal to 12 pi. So 12 pi is equal to 2 pi f, from which f is equal to 12 pi by 2 pi. So t is equal to 2 pi by 12 pi, which is equal to 1 by 6. So we have a t as a ratio of two integers. Hence the signal is periodic. Let's go for the third question. X of t is equal to e power j 4 pi t. So omega is equal to 4 pi. So 4 pi is equal to 2 pi f. So f is equal to 4 pi by 2 pi. T is equal to 1 by 2. Ratio of two integers. Hence we can call this signal as a periodic signal. Next question. X of t is equal to e power minus mod t. So mod t means t can be either positive or t can be either negative. So when we draw for the signal, when t is positive, we have a decaying exponential. When t is negative, we have a rising exponential. So whenever we have rising and decaying exponential, the signal is not periodic. All the exponential signals are aperiodic signals. Let's take next question. X of t is equal to cos 2t plus sine root 3t. Here we have a combination of two signals. This cos 2t will be having its time period and sine of root 3t will be having its own time period. So we'll have two omegas over here, omega 1, omega 2. Omega 1 is equal to t, from which t is equal to 2 pi by omega. So t1 is equal to 2 pi by 2. Similarly, omega 2 is equal to root 3. So t2 is equal to 2 pi by root 3. We have two time periods, t1 and t2. Here both we have to find fundamental time period here, combination of two things. So t is equal to t1 by t2. So t1 by t2 I will be getting root 3 by 2. So this root 3 by 2 is not rational number. So t is irrational, hence the signal is aperiodic signal. If it is 3 by 2, then the ratio is rational, then we can call the signal as periodic. Now it is root 3 by 2, hence it is irrational, signal is aperiodic signal. Last example for us, x of t is equal to sine 10t plus 1 minus 2 cos 5t plus 2. This is phase shift. Sine omega t plus 5. Don't worry about the phase angle, whatever may be the value given, you have to worry only about the frequency, omega value over here. Here omega 1 is equal to 10, from which t1 is equal to 2 pi by 10. Similarly, omega 2 is equal to 5, from which T2 is equal to 2 pi by 5. Now we have to find T is equal to T1 by T2, which means I'll be getting 1 by 2 seconds, which means T is a ratio of two integers, hence the signal is periodic signals. In addition to this, if a question is to find, addition to finding periodicity nature, if you are asked to find the fundamental time period, means how to find. The fundamental time period T is equal to T1 by T2. So I can write that is equal to answer 1 by 2. The value what we got is 1 by 2. So T is equal to T1 by T2, that is equal to 1 by 2, which means either T is equal to 2T1 or T is equal to T2. When we equate this, I will be getting T equal to T1 or T equal to T2. Both are correct. So I have a value for T1, I have a value for T2. Let me substitute this over here. So T is equal to 2 into T1 value, 2 pi by 10, which means I will be getting 2 pi by 5. Or T2 value, 2 pi by 5. Both are correct. I have to use either this value or this value. So both are correct. So now in this video, you are able to identify whether the given signal is periodic or not, as well as you have been taught how to find the fundamental time period of any signal. Thank you all. We'll meet again in the next video.